Hello and welcome. In this video, I will explain you the concept of reusable cover group with respect to system Verilog functional coverage. And by this example, you will understand how you can write a code or cover group which is reusable in nature. So if you want to change the bins in the future, then no need to write the entire code or no need to do a modification in the entire code. With the help of little modification, you can find the or you can get the expected result from the code. Okay, and here I have taken a very simple example, and I have taken a module based example to understand this concept. Okay, now you can see I have defined a module, a reusable cover group. In that I have defined a logic variable which is of 4-bit. Mode is a variable name which is of logic type, and as you know, 2 raised to power 4 is equal to 16 combinations are possible. So here we are writing a bins explicitly, vector bins. So they will 16 0 to 15. Okay, and as you can see, cover group CG, within parenthesis I have written a ref variable which is of logic type, same as this variable whatever we have defined here, and size need to be same, 3 down to 0. If you give a different size, then the simulator will throw an error. You can try it by yourself. Now input is int type. I'm giving a range for this bins, lower and higher, reusable in nature, and input is string for identifying the our operations like arithmetic, logical, shift and jump operation. For them we are declaring a bins. So the goal of this example is to generate a different bins. For example, 0 to 3 is for arithmetic operation, 4 to 7 is for logical, similarly 8 to 11 for shift, and 12 to 15 for jump operation. Okay, now as you can see here, this is what the cover group. Now after that, option dot per instance is equal to 1. We need to give this in order to get the detailed analysis of the coverage report. And another one is option dot name, and I have assigned this to the instance name which we have declared as a input string type for different operations. Okay, to see that operations in the coverage report. Now this is what the label CP for cover point. You can give any label, cover point, and this is what the var name which we have declared as a ref type. Okay, for this we are writing and it will refer to this mode. Okay, and this curly brace, in that I have written a vector bins bin is a name, and a square bracket is indicates the vector bins, and within curly brace I have written lower and higher range. This is what we have defined here as an input type, int and input type. Okay, and end group, I'm ending this cover group here, and these are 4 instances for that cover group, CG1, CG2 up to CG4. And within initial begin block, I am allocating a range and name. So this CG1 is equal to new, within parenthesis mode, which is nothing but our variable mode, and 0 to 3 is a range. Okay, and arithmetic operation within double quote we are providing, so this will nothing but an string, right, instance name. Similarly, CG2 is equal to new mode, for this our mode variable, and 4 to 7 for logical, and similarly for 8 to 11 shift operation, and 12 to 15 for jump operation. This is how we can make a reusability, increase the reusability of our cover group. And within forever begin block, you can write a repeat also, but if you are repeating 10 times or 20 times, you are not getting the 100% coverage. And for getting that 100% coverage, I am writing this forever begin block. Okay, mode is equal to $u random, I'm assigning a random values for this mode variable. Okay, and this is what the sample method, inbuilt sample method of the functional coverage, and this is what the instance cg1 dot sample. We are sampling all these instances here, and after after 10 time unit we are generating a different random values. Okay, and this is what the end of this forever begin and end of this initial begin block. Okay, and initial begin, I'm declaring a 500 time unit of delay, and after that I'm stopping the simulation. It is must if, because we are giving the forever begin block. And this is what the you can easily understand what this is, a reusable cover group. Okay, and we will try to run this code and we will see. So control save and control S for save and control enter for running the code. So you can see the output result here. Okay, so what the report we are getting, we will try to understand. We are getting the 100% coverage because we have written a forever begin, right? Forever block we have written, so for that we are getting 100%. Okay, now if you can see mode 0 to 3 arithmetic operation, so you can see that bins are 0 to 3. Okay, this is what the bins we have declared, lower and higher variable, and 0 to 3 for arithmetic operation. This is what the instance name, and it need to be hit one time, but as you can see either here 4 times this bin is hitting, and 6 times, and 1 and 4, so all the bins are hitting. Okay, so we are getting 100% for that particular instance arithmetic operation. And for second instance logical operation, you can see here we have 4 to 7 logical, so 4 to 7 are for logical, and we are also getting 100% here. And for shift operation 8 to 11 for shift operation, and instance name is jump operation 12 to 15, we are also getting 100% coverage. So this is what you can easily analyze, and you can easily find that a reusable cover group have you can make. Okay, let me comment this option dot per instance is equal to 1. So if you comment this and you run the code, you will find that the detail will not be there. Okay, let me run this code. So as you can see, bins are not showing here. So this is what the importance of that option dot per instance is equal to 1. Okay, and this is what the option dot name is equal to instance in it. If we commented this, then we I think it is difficult for us to find that instance name which we have given this arithmetic operation and logical and shift and jump. Okay, so you can see unnamed it is showing. Okay, so for giving that name to that particular bins, we are using dot option dot name is equal to 1, so that it will generate the meaningful data. Okay, and you can see the same result which we have got first. Okay, so this is what the concept of reusable cover group, and you can try this by changing a different size and changing the values here, and you will find it little simple and interesting to see the reusable cover group. Okay, so I hope with this you have understood the concept of reusable cover group. I hope you have enjoyed this video. So thanks for watching. Thank you.